Okay, this is a formula derivation exercise called the Heron's theorem, derivation, the Heron theorem derivation. Basically, what it states is when we have a regular triangle, and I will use the bracket as to that to call a triangle, and this means the area of a triangle ABC. In reality, we're in this. Well, let's talk about the theorem first. That states that the area of a triangle is equal to the square root of s minus a, s minus b, and s minus c. I bet you've never seen that formula before. A regular triangle, let's say, I'll make a small triangle here. Because it's important that this triangle has a 90-degree angle. This is called the right triangle. And if we're looking for the area of the right triangle, we will have a height, we will have a base, and we will have a hypotenuse, which we call C. And we'll call this triangle the triangle small a, small b, small c. So the area of this triangle, normally this is what you see, A, B, C, is equal to 1/2 times the base times the height. That's the regular. That's a regular formula. There's other formulas that I would talk about when they become, when it's, when I see it fit. Maybe on the next problem that has to do with triangles. I have a lot of beautiful, very nice problems dealing with triangles, but they're very, very, I would say, difficult if you know what you're doing. But normally I didn't know what I was doing. So it's some of these triangle problems are very nice, beautiful. I mean, like I said, I really love it when you start thinking, using your head, and you find the way of doing it. It's like I said, I tell you, some of them are very, 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 very clever. Okay, so I need to move really fast. I'd like to mention also that, because I mentioned it, in my in before, that the area of this triangle comes from the fact that, and it looks like a square, but I'm going to assume that this is not a square. This is a rectangle. Okay, I know it looks like a square. It is pretty much like a square, but I'm going to assume we're going to assume that this is not a complete square. The point that I want to make is that this formula comes from the fact that if you look at this, well, even though the B is over here and the H, well, I use B and H, but we can think of it as the area of the square, and we are not going to use letters, is equal to A times B. But if we cut it in half, it's just the same as the area of the triangle. 1/2 A times B. Okay? I just wanted to mention that because since we derive in this formula, we should mention where this formula comes from. Okay, so with that said, we're going to start with this thing. Okay, so to start with, we're going to talk about a couple of things, The perimeter of a triangle is equal to the size, the addition of the sides. So in this case will be A plus B plus C is equal to the perimeter. But there's another thing called the semiperimeter, that's what that is. That S there is equal to half is P divided by 2. This implies that P is equal to 2S. Okay? And another formula that I'm going to talk about that I'm going to be using so that you will not be surprised is A plus B squared is equal to A squared plus 2AB plus B squared. This comes when you take this and you multiply by itself, A plus B times A plus B, then you multiply the first A by the next A, and you get A squared, then you get A times B, but you get 2A times B. I'll do it real quickly here. You multiply like this and like this, and then you multiply like this and like that. I know it's a mess, but you get the point. Then you get A times squared, and then you get 2AB plus AB, this AB, and then this AB plus B squared, and this turns into 2AB plus B squared. The other formula, that another math identity, which I call identity, but is only used in trigonometry. But I like to call it identity because it works almost the same way, kind of. Is this one, A squared minus B squared is equal to A plus B times A minus B. Okay? And we also should mention the fact that in the Pythagorean theorem, Pythagorean, I wouldn't write it because I'm not sure how to spell it. But the Pythagorean theorem says that in a triangle, let's say, well, in a triangle, I'll write it real quickly here because I wanna make sure you understand where it's coming from. This is C and this is A and this is B. And so, in a triangle, the hypotenuse. Remember, this is a 90-degree angle, which means that this is called the right triangle. In a right triangle, the hypotenuse C is equal to A squared plus B squared. That's a typical. What other formula I have? I think those are all the formulas that we are going to be using in our thing. So we're going to start real quickly. We're going to start with the fact that this B here, which is the distance between A and C, is made out of P plus Q. So we start with that. This is the beginning of this process. The process, what we're going to do is that we're going to come up, we have to determine the H value. But we're going to use this triangle here, the triangle BMC. We're going to find what that triangle is. And also we're going to find H, but using this other triangle here, the triangle BMA. Okay, so we start with this fact here, with B is equal to P plus Q, which this implies, let me see, where are we going? Okay, I see. That means that this implies that Q is equal to B minus P. Okay? And so we're going to, in this triangle here, see we have so many triangles. Okay. In this triangle here, we can say that A squared is equal to H squared plus Q squared. Pythagorean theorems, yeah, from here. But we can substitute this Q in here, and we get A squared is equal to H squared plus parentheses B minus P squared. See this? And see this? We're going to use this identity to substitute it with this. So that implies that A squared equals to H squared plus, and we're going to substitute, we're going to use this in here. So what does that mean? Well, it means that we're going to use a parentheses, B squared minus And we can put the minus here so that when in the parentheses we use the plus on top, we get a plus on top here. This plus always stays the same. And when it's a minus, then the first one is a minus and the second is always a positive. 2bp plus p squared. Okay? Okay. BP, okay. In this triangle, we can use Pythagorean theorem. Wait, hold on. In this triangle here, we can use Pythagorean theorem between H, P, and C, and we can say that the hypotenuse C squared is equal to H squared plus P squared. Yeah? Okay. From this formula, from here, we're going to take the parentheses out and we're going to group this term here and these terms here. They are the same as those two. So we're going to use a squared. We're going to say x squared is equal to h squared plus p squared. And we eliminating the parentheses. P squared minus 2bp. And that's it. Okay? So we can substitute this by c squared. And so we get a squared equal to c squared plus b squared minus 2bp. From here, we're going to isolate the p alone. You'll see why. This implies that when we move this over here and then the 8 inside and then we get rid of the 2p, we can do it in one shot. P is equal to c squared plus b squared. The 8, we put it inside, it goes minus a squared. And then we put, this goes positive inside, this goes negative inside there. And so the BP, or being the 2B, goes underneath. Okay? This is all the formulas are important, obviously. But this is quite special, I would say. Okay, so again, from the fact that we have c squared equal to, yes, c squared equal to h squared plus p squared from this triangle here, we're going to prepare the main formula. I mean, one of the most important part of this whole thing, which is getting h squared alone. So we move the p over there, so we get c squared plus p squared. Whoops, not quite. I wish I can get rid of this thing here. But I don't have nothing to, so I'm going to redo it. It's a squared is c squared minus b squared. Okay? Okay, so now we can take this b and put it inside this formula. And we get, that implies the h squared is equal to c squared minus b squared. Minus b squared. Let me see something. Okay. From this math identity, remember, they're not called identities. Only me in the whole wide world calls it that. So don't get used to it. It's mine only. This implies that h squared is equal to two parentheses, c plus p and c minus p. Okay, this is from this thing here. So now we can take this p and put it inside here. And so that implies that h squared is equal to parentheses c plus p, but p is all this stuff here. C squared plus b squared minus a squared ¿verdad? And 2b. And I'm going to try to squeeze this here. Then we have c minus, because of the minus, we're going to use a parenthesis here. Very important. So we put the same p again. C squared plus b squared minus a squared, parentheses, you see, I knew I was not going to be able to squeeze it in there, 2p, 2b. I'll write it again on this side so to clean it up. I don't like that mess over there. It looks confusing. H squared is equal to parenthesis c plus c squared plus b squared minus a squared divided by 2b, parentheses c minus parentheses c squared plus b squared minus a squared divided by 2b, parentheses, parentheses. Now we have to get, I call it finding the greatest common factor between these two. Remember, there's a 1 here and there is a 1 here, so we can actually put all this stuff on the one line, which means then this implies that we're going to, in order to do that, what we do is that we put parentheses and we put our line there and we put our 2b, and then we divide db divided by 1 is db times c is 2bc. 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 Yes, this is 2bc. Plus c squared plus b squared minus a squared parentheses. And this is going to be another mess again. I'm going to see if I can squeeze it in there. The same thing over here. We put a single line and we put a 2b underneath. And so we do the same thing. We divide db by 1 times c. So we get 2bc again minus parentheses c squared, and b divided by b is 1 times this is the same thing over here. I think I forgot to say it. You know, like b divided by b is 1 times this thing on the top is the same. So that's how it happens. I forgot to mention it on this side. And so this is plus b squared and minus a squared. And we can close the parentheses. This is not so bad, so we're gonna leave it like that. We're not gonna repeat it. When we look at this stuff, we can see a c squared, a b squared, and a 2bc. Does it look like something you've seen before? Yes, it looks like this. A plus b squared, a squared, a is equal to a squared plus 2ab plus b squared. The only thing is that in this case they use bc, you know, instead of ab. So we're going to substitute this point, that point, and that point. Okay, so that implies that this thing here is equal to, let me write my h squared is equal to, and we're going to open a parentheses. Yeah, well, I don't think yes, I need the parentheses. I need the parentheses, another parentheses. And I'm going to write BC, B plus C squared. And so when I have only left minus A squared, all divided by 2B, and we close the parentheses, and we do the same thing in here. But before we do that, I'm going to add one. I have to add one more step because I have to eliminate this parentheses. To eliminate these parentheses, I have to multiply everything in this parenthesis by -1, which means that it changes all the signs inside. So that means that 2bc minus c squared minus b squared plus a squared divided by 2b. And as we did before, well, let me see something. Okay, this, I'm going to rewrite this term. I don't want to squeeze anything in there, so I'm just going to go here and write x squared. I'm going to rewrite the first term, b plus c squared minus a squared divided by 2b. And then on this side, I'm going to group, remember this, the 2bc, c squared, and b squared are like this here. Same thing. But I'm going to group them first, and I'm going to write them properly, but I'm going to write them as b b squared plus 2bc minus, no, this should be minus b squared, and this would be 2bc plus 2bc, and then minus c squared, which is the opposite, which this is what I wanted to see, I wanted to show you. So there, I'm going to put a parenthesis here, and a parenthesis there, and I'm going to write the 8 alone. And now I'm going to show you why I'm doing that. This implies x squared is equal to, and I would rewrite this term again by itself, b plus c squared minus 8 squared divided by 2b. And then I'm going to multiply this by -1. And you'll see why I do that. So this will be minus, and then this will be b squared. This changed to a minus, and minus 2bc, and this changed to a plus. B underneath. Now I can group them. Well, yeah. Now I can change this to something like this over here. So we rewrite this again, h squared equal to b plus c squared minus a squared divided by 2b. And then we'll have minus okay. Oh, I missed something here. The C, the A is missing. So I'll erase this parenthesis here, and I'll put the plus A squared and put the parenthesis. Okay? Sorry about the mess. Okay, so now we can write the term. We're going to substitute this by what we have up here. And so we have b minus c squared plus a squared divided by 2b. This implies h squared is equal to, and we can leave it like that. In any case, this thing up here looks like this: a term squared minus another term squared, and then we can write it like this. Okay, so I'm going to rewrite this real quickly. B plus c squared minus a squared divided by 2b, parentheses, another parentheses. I'm going to move these guys. Let me see. This a little bit, I'm just gonna just gonna rewrite it like that. I was just checking something. Minus b minus c squared plus a squared. Close parentheses, 2b. This, you can see a term to the square minus a to the square looks like this. So we're going to split it. We're going to split this thing. The same thing happens here. Okay? What was a little bit confusing is about that negative sign, but we'll deal with it later. So this implies that h squared is equal to, when we split this open, we basically gonna lose the parentheses and the squares. The squares are gonna go away. But this is gonna create two parentheses, you know, and this one is gonna create another 2 parentheses. We're gonna have 4 terms. And then we're gonna join these things, multiply this times this. Okay, so then we get b plus c minus a parentheses, yeah, and then we get another term which is the same but with this sign changed. And the same thing we do on the other side. Let me see if this works. Minus, well, I'm gonna just because of the minus sign there, minus bc plus c, and the first term we use minus and then plus. Okay, so I'll use minus a squared remember I'm changing the sign here, and then I'm going to do it again. Minus b plus c, and this one is plus a. Yes. Let's see how that. Okay, this is wrong. In order to make this work properly, I'll rewrite it here, h squared, and I'll explain it. B plus c minus a, b plus c plus a, and then here I will switch them around, put this term here and that term over here. So there will be a squared minus b minus c squared. This is equal to h squared, and these terms stay the same. And I'm going to squeeze them a little bit because I want the whole thing to fit in there. C plus A, and so that, you know, because it need to look like this, yeah, A minus B. So that's why I switch them around. So when we do that, we get A plus B minus C and the last parenthesis will be A minus B minus C parentheses. So I'll just write it here again. B plus C minus A, B plus C plus A, and this one, this term here, A plus B minus C. I know a little bit squishy here, and this will eliminate the parentheses, and we get A minus B plus C. And notice I swallowed these terms here, so I'll erase these two because I rewrote the whole thing here, and I would write it here. Okay, so it's missing there, so I'll write it 4b squared, okay, because we multiply this time this and we get 4b squared. Okay, now there is this thing here that we're gonna do that is a little bit tricky. We said that 2s is equal to p, you know? This looks like p, but p doesn't have a negative term yet. You can see that this in each of these, all these parentheses are different. On this one, the a is minus. On this one, they're all positive. On this one, c is negative, and on this one, b is negative. Okay, so in order to fix that, we can change the first one with all the things are good. We can change it by s. Wait a minute. Okay, so I'll do it really quickly here. I see this is equal to p. Okay, but p, where's p? Right there. P is equal to 2s. Okay, so we can replace that first term. This will be equal to h squared is equal to the first term. We're gonna cancel this guy. We're gonna put 2s. And this parentheses, in order to make this, what we're gonna do is we're gonna do 2s. You can see this, 2s minus 2a is equal to b plus c minus a. How is that possible? Because if we replace 2s 2s s is equal to a plus b plus c divided by 2. Okay, so we can cancel those two, but then we have this minus 2a here. So we get a plus b plus c minus 2a. This a will cancel out with one of these a's, and it will leave behind a, let's say, minus a plus B plus C, which is what we want. Plus B plus C plus minus A. So what we're saying is that we can replace this by this. Yeah? We can replace that, and then this will be 2s minus 2a. The next one is the same thing, but with the c. So the next parenthesis, this parenthesis will be 2s minus 2c, and the next parenthesis will be 2s minus 2b, all divided by 4b squared. Okay, we can take a 2 out of this parentheses, factor out a 2. From this parenthesis we can factor a 2. From this parenthesis we can factor a 2. And then we can multiply them that's 4, 8, and 16. So h squared will be equal to 16 16s divided by 4b squared, and then all those parentheses, but without the 2's. So there will be s minus a, s minus b, and s minus c. From the formula of the triangle, from upstairs here, the area of the square of the triangle is equal to the base. I mean, 1/2 the base times the height. I mean, times the height. Okay, so, but here we have x squared. Okay, I'm gonna have to do it on the next page here. So we can clean up the h by squaring this and then squaring this, and then we get square root of 16 divided by 4 b squared s minus a, s minus b, s minus c. Okay, and so we can cancel this with that and cancel a b, so h will stay. Well, we can take the 4 out. We have a 4 remaining there, and when we have this b square, we can take them out of the square root. So we get 2 divided by b, square root of s minus a, s minus b, s minus c. Okay, then we integrate it into this formula. We put the h there, and so the area of the triangle will be equal, you can see, yes, the area of the triangle will be equal to b, well, 1/2 of b times h, and h will replace it by this, which is will be 2 divided by b, the square root of s minus a, s minus b, s minus c, and this will go up with this go up with that, And so the area of the triangle, I'll move it here. The area of the triangle will be equal to the square root of s minus a, s minus b, s minus c, and we are finished. We prove Heron's theorem. Right? And in this square, we don't use plus minus because there's no such thing as a negative area. So no need to go there. But I just wanted to mention that. I don't know what else I want to mention before we go away. Yeah, this is it. This is it. You know, it's a complicated. It's a little complicated, but it's all math manipulation. And at the end, you can see that we get our formula here, same as this. To me, this is pretty. I will be doing more of this stuff, you know, and there's a lot of other problems that I have in my notes. I have lots of notes, and so I will come up with the next one. Okay. Wow, this is very long. Okay, though. Take care. Don't forget to subscribe. There's a button in the right corner there on the bottom. You just hit that button there. You can subscribe to my channel. Don't forget to like it if you like it, and leave a comment if you don't mind. Whatever you like, you know. Maybe I'm too slow. Maybe I make too many mistakes. You know, I can't see the stuff. Whatever. You know, anything that can help me out, you know, will work. Okay. Thank you for watching, and take care. See you in the next video.